more expensive than gold. In 2022, lithium reached over $80,000 per ton, even surpassing the price of gold per kilo. Bolivia holds the treasure. The Uyuni salt flat contains 25% of the world's lithium reserves, though it's still not fully exploited. Australia, the production king. While South America has the reserves, Australia is the largest producer and exporter. A winning business. Every electric car needs lithium, between 10 and 15 kilos per battery. Without lithium, there's no electric mobility. Demand is about to skyrocket. By 2030, it's estimated to increase fivefold. An absolute surge driven by cars and clean energy. Extraction consumes water. Extracting 1 ton from salt flats can require up to 2 million liters, affecting local communities. It can now be recycled. Lithium can be recovered from used batteries, and this technology is advancing rapidly. It's everywhere. Also in phones, computers, solar panels, and even pacemakers. It's closer than you think. An ally against climate change. Key for renewable energy. It allows storage of solar and wind power. But it's also geopolitical. Like oil, lithium is already generating tensions over its control. The new white gold. So if you want to know how this resource that's changing the way we live is extracted, how it becomes a key component of the batteries powering the future, and what challenges we face in its extraction, stay with us. Don't forget to subscribe, hit that like button, and share this video. Let's begin the journey into lithium. Step 1. Identifying lithium deposits. The first step in obtaining lithium is identifying the deposits where this mineral is found. Lithium deposits are mainly located in 2 types of geological formations: salt flats and hard rock deposits. Salt flats, like the Uyuni salt flat in Bolivia, are large salt expanses containing underground water rich in lithium. This groundwater is extracted and evaporated to concentrate the lithium. In other regions, like Australia, lithium is found in hard rock minerals such as spodumene. Geologists use a combination of geophysical and geological exploration methods to identify these sources. Drilling is performed to obtain subsurface samples, chemical and geological characteristics are analyzed, and the quality and quantity of lithium present is evaluated. Soil studies, geophysical surveys, and satellite imagery are essential tools for locating these deposits. Once lithium deposits are identified, environmental conditions and economic viability are evaluated to determine whether extraction is profitable. These deposits aren't only in South America but are also found in places like Australia, China, and Africa. Without proper identification of these deposits, the extraction process wouldn't be possible. Step 2. Extracting lithium from salt flats, mines, and clays. Lithium extraction begins at the deposits, which are found in various geological formations. Salt flats, like those located in the Lithium Triangle, Argentina, Chile, and Bolivia, are the most common sources, where the mineral is dissolved in large quantities of salt water. This lithium-rich water is pumped to the surface from underground salt flats. In other areas, lithium is obtained from hard rock mines, like those found in Australia, where the mineral is extracted from pegmatites, igneous rocks rich in minerals, containing spodumene, a mineral that's processed to obtain lithium. In these mines, the mineral is extracted using traditional mining techniques, such as explosives and heavy machinery, to then be crushed and processed. Additionally, lithium can also be extracted from clays containing lithium concentrations in the form of minerals like lepidolite. This process, though not as common as salt flats and mines, is gaining ground due to technological advances in treating these rocks. Once extracted, lithium continues its journey to the next process, where it will be concentrated to finally become a suitable material for manufacturing batteries and other key products in modern technology. Step 3. Water evaporation to concentrate lithium. Once the lithium-rich water is extracted from the salt flats, the evaporation process begins. This is a crucial step, as it allows lithium to be concentrated and remaining water to be separated. In large evaporation ponds, water is left to evaporate naturally thanks to the sun's heat, which leads to the concentration of minerals present in the solution. Over months, water gradually evaporates, leaving behind a mixture more concentrated in salts, especially lithium. This process is so slow and climate-dependent that in some areas, it can take up to a year for the process to complete. As lithium concentration increases, so do impurities, which are separated through additional processes. Evaporation is one of the most economical ways to extract lithium, as it takes advantage of the natural environmental conditions, although the process is slow and depends largely on factors like climate and available sunlight. This step is essential for preparing lithium in a more concentrated form, which facilitates its subsequent treatment and conversion into products like lithium carbonate. Step 4. Precipitating lithium as lithium carbonate. After concentrating lithium in evaporation ponds, the next step is converting it into a more suitable compound for use, like lithium carbonate. This process is performed by adding chemical reagents, such as sodium carbonate, Na2CO3, to the lithium-rich solution. When these reagents are added, lithium combines with other substances and forms lithium carbonate crystals, Li2CO3, a solid compound. Once the crystals have formed, filtration proceeds, separating the lithium carbonate from the rest of the solution. These crystals are then washed and dried to ensure they're free of impurities. In some cases, lithium carbonate may undergo an additional purification process to guarantee it meets the high-quality standards required, especially for applications like electric vehicle batteries, which demand high-purity lithium. This step is crucial because it transforms lithium into a usable form that can be employed in battery manufacturing, an essential component for the advancement of electric car technology and portable devices. Step 5. Refining and purifying lithium. Once extracted, lithium needs to be refined and purified to be suitable for use in batteries and electronic devices. This process ensures that lithium is high quality, free of impurities, and suitable for industrial applications. The refining process begins with the removal of impurities through ion exchange or chemical precipitation. In ion exchange, lithium passes through specialized resins that separate it from other unwanted metals, like magnesium or calcium. In chemical precipitation, lithium is mixed with reagents that convert it into compounds like lithium carbonate or lithium hydroxide, which are then separated from remaining minerals. Once purified, lithium is dried and transformed into products suitable for use in manufacturing lithium-ion batteries, essential for electric cars and portable electronic devices. This step is crucial, as lithium must meet strict purity standards to guarantee its effectiveness and durability in the batteries that power our modern technology. Lithium purification ensures it's a reliable and efficient material for the future of clean energy and technological innovations. Step 6. Manufacturing lithium compounds for batteries. Once refined and purified, lithium must be converted into specific compounds to be used in battery manufacturing. The most common are lithium carbonate, Li2CO3, and lithium hydroxide, LiOH. Both compounds are essential in manufacturing rechargeable batteries, especially lithium-ion batteries. Lithium carbonate is obtained through a chemical process where lithium is mixed with carbonic acid or its derivatives. This compound is mainly used for lithium-ion batteries. On the other hand, lithium hydroxide is produced by reacting lithium carbonate with lime, calcium oxide, which results in hydroxide. This compound is key in producing batteries for electric vehicles, as it helps improve battery stability and efficiency. These lithium compounds are vital in manufacturing lithium-ion batteries, known for their high energy storage capacity and efficiency. They're fundamental in portable electronic devices and electric cars, enabling a cleaner and more sustainable energy future. This step converts extracted lithium into a key resource for modern technology and energy transition. Step 7. Application in batteries and electric technology. Once lithium has been refined and converted into suitable compounds, the next crucial step is its application in batteries and electric technology. Lithium is a key material for rechargeable lithium-ion batteries, which are used in a wide variety of devices, from smartphones and laptops to electric cars and renewable energy storage systems. Lithium carbonate and lithium hydroxide are the most common compounds used in lithium battery manufacturing, thanks to their high energy density and ability to maintain a charge for long periods. These batteries are lighter and more efficient compared to other technologies, making them the preferred choice for electric vehicles. In addition to their use in electric vehicles, lithium batteries also play a vital role in renewable energy storage, such as solar and wind power. These technologies depend on batteries capable of efficiently storing large amounts of energy, which allows using electricity generated at times when there's no sun or wind. Lithium, being an essential component for electric technologies, has become the mineral of the future, driving an energy revolution and contributing to the development of clean and sustainable energies. And there you have it. The fascinating process of lithium extraction, a mineral that's driving the technological and energy revolution of the future. From salt flats to the batteries that power our devices and electric cars, lithium is transforming the world. If you're amazed by everything involved in its extraction and applications, don't hesitate to leave us your opinion in the comments. What do you think about lithium's impact on clean energy and technology? If you enjoyed the video, subscribe, hit that like button, and share for more interesting content. See you in the next video.